How are you?
Hi.
How are you?
Good.
I thought this was on the other side, so I'm
Oh,
going back and forth.
Yeah, this hotel has a layout. It's not ideal if you have meetings on opposite sides. It's
Yeah.
running here.
Yeah, no, I was next door, but then I thought this was there. And so I went there. And I come into this room and nothing. Someone else is sitting there. Okay.
Okay, since you're there, I think we can start.
How are you?
Okay. Okay. Welcome, everyone. You are at the LISP working group meeting. This is not a jump in the past, it's my mistake. I left IETF115, just uploaded a new deck, but apparently the system doesn't update regularly. Anyway, the note, well, you signed it. Everything we speak today here is a contribution. Okay. The usual tips, if you didn't do it yet, please log in the Mitico, in the client tool, and this is also automatically signing the blue sheets, okay? For people remote, please use the full client, okay? Code of conduct, I love to put this slide just to remind to everyone that we are here to speak technically and we have to respect each other each and every time. The usual admin slide. We have some news. Padma here is the new co-chair. Okay, I welcome her. I was hoping that Joel was here for the beginning of this session because I actually have an award for him for a decade-long working group chair. You cannot read here, but as a typical IETF style, I have this for him, if you can read, and on the back. Can you read that? I will give it to him as soon as I can. He did a wonderful job. We reached a good milestone with the main specification.
Can you take a picture of the t-shirt and send it to the mailing list?
I will do it. It's a good idea. Anyway, on the screen you have the usual pointers, the Zulip room, audio stream, Mitico. As I said, please log in on the on-site and remote stream, okay? And everything is on the data tracker concerning the material. Good news, we have 8 new documents that have been published since 114. As I said, this is also the merit of Joel that did quite some work on that. This is an important milestone because finally we can focus on other work, okay? We also have the freedom to recharter and discuss on what we want to focus, okay? This later on today. There are a few documents that are already in the pipeline. I have the name encoding, Hexagon, PubSub, and Young. Young is close, actually. We should start to push that one. We will have today an update of a couple of those documents, okay? And last slide from our side is the agenda. So we will have Sharon giving us an update on Hexagon. Then we have Dino with the geo coordinate and the satellite networks. This is the right order you asked? Okay, we updated the agenda. We switched these two presentation because Dino asked for is better for him. We have Prakash with the site external connectivity. There is a last-minute request from Alberto to give a short update on PubSub. So after Prakash, we will take the mic for a couple of minutes, and then all the time left to start discussing on rechartering. Okay. So unless there are further comments, I guess we can switch to Sharon. Okay. Okay. Let me. Sharon, are you online? Yeah.
Yes. Yes. I
Give me
apologize
a
for
second.
the travel restriction.
It's okay. We hear you loud and clear. Go ahead.
Okay, it's more NASDAQ related than COVID related, but whatever. All right, so I would like to share with you a few updates on this Hexagon since Vienna. To relate to the AD review and to relate more to industry developments which are associated with the draft. Next, please. Okay, so as everybody is pretty much aware by now, the draft combines geospatial grid IDs and LISP EIDs for mobility geolocation networking. Just starting this effort, there were two potential choices for grids, S2 and H3. But since S2 is more geometry, mapping, GIS, Atlas kind of oriented, H3 was better suited for dynamic real-time conditions, what we attempted to do, real-time network, aggregation, addressing, because of its simple hierarchy and simple neighbor propagation. As requested by Alvaro, we added an LCAF for clearly encoding H3 IDs into EIDs with the kind help of Dino and Alberto. So you can see those, they are now in a draft. We also updated the references from the BIS to the actual RFCs. Congratulations, everyone. Next, the network is addressed and the packets are keyed by H3 IDs for values based on BDD taxonomy. So it was requested by Alvaro that these two consortiums review the draft. H3org was kind enough and really excited about the new networking use for their grid, but pointed out one issue which relates to hexagonal hierarchy. It's basically the fact that hexagons are great for neighboring and they're like a circle, but they're like not a circle, which is good. So they tile, but in hierarchy, it may happen if the delta between the detection resolution and the EID resolution is too far, the detection resolution may actually be outside the EID area. So that was pointed out, and the suggestion by H3 was not to go up the tree farther to get from the detection ID to the EID, but rather to ask for the center of the detection tile and then ask for the EID of that center so that we get the correct EID resolution. So that was fixed in the draft. BDD was asked to confirm that the enumeration of detections outlined in the draft and assumed more or less localization ability around 50 meters that can be consolidated by EIDs is reasonable for a moving vehicle with reasonable onboard computing. They confirmed that. Offline, they said they really recommended that when we enumerate speed limit signs, we actually read them. What is the speed limit? Because these signs keep changing a lot. So we did add that to the enumeration. Next. So far, this is for the draft relating to the review, and I would like just to say I apologize for the number of the revisions. As I discussed with Joel, I have some challenges with written English sentence structure. So sometimes I write something, it looks perfect, and then it just unintelligible. So apologize for that. Next, as far as industry, up, please. Go up. Yes, thank you. So the ACC has made public an interoperable multi-party test that detected free parking spaces in Tokyo based on Hexagon. KDDI provided the access, Oracle provided the edge compute locations. The network locations between access and edge were tied up by hosted RTRs. Nexar provided the AI CarCam stack and the AI consolidation stack, but really this is unlikely that one vendor will provide both because there are many equipment gear vendors and multiple mobility service providers, but that was good enough for the test. The RTR pickups were analyzed by KDDIs and were used to prove that the steering worked, meaning based on your location, the uploads were steered to the location of the Nexagon, where the Nexagon is right now, and it could be in either sites. That subscription to Nexagons for areas of interest worked, and no matter where the Nexagon was, the signal-free multicast found the vehicle. There was subscription continuity and geo-privacy, meaning no tracking based on the vehicle EIDs. The PSCs now would be extended to more detections, more vehicles, and more geospatial areas now in the US. Next. An additional POC that will be made public will dramatically increase the frog fragmentation aspect of the setup. Cisco Wi-Fi private 5G breakouts will be used to upload and subscribe to a much higher distribution than edge data centers, more like servers in Toyota gas stations or dealerships, and that will be a lot more fragmented, and this will push the LISP aspects much stronger than the initial POC did. But these reflect industry trends for green, low cost and high capacity connected mobility. It's a strong pressure. Okay, next. Okay, so this brings us to additional industry-related trend, which we hope to prove through Nexagons and can be generalized later, of automotive digital twins, meaning Nexagons is a twin of the street, but there's twins of the vehicles and the drivers and so on. In principle, digital twins are based on connected sensors for compute objects which reflect some kind of asset. So this has little to do with the LISP. As you can see in the drawing in the middle, it's just connected sensor to a digital object. But if we examine a few differences between digital twins in like a closed domain, like a factory, versus an open field like a city, we see clearly why LISP and CAN, if you have been to the BOF yesterday, are clearly valid. For example, in a factory, I may have a twin of an engine or 1,000 engines, but in the city, I may have in the day millions of engines, and at night just 1,000 engines. So that's the difference between half a servers and hundreds of servers. Same for the street. A lot more busy, a lot more detections during the day. So we need that kind of elastic steering. Also, in a factory, there'll be a stable access. In the city, there'll be multiple providers and breakouts. So that's very fluid and requires LISP abilities. And as far as sensors, like in a factory or a testing track, I will have fixed sensors for every segment of the track or a wind tunnel. In the city, the vehicles are the sensors. So 1 minute, the vehicle is a sensor for one segment. The next minute is a sensor for another segment. And that kind of dynamics also lends itself to LISP. Also, geoprivacy and preventing tracking, not relevant in a factory, very relevant in a field. To that, we add the fragmentation we talked about. And that fragmentation was brought up yesterday in the, it was brought up yesterday in the BOF, and it's very real, and it has very strong economical push. So the fragmentation, which is supported by Lisp Nexagon, allows geospatial twins to expand and occupy more edge locations. So edge locations are considerably cheaper as far as GPU than cloud. The reason is that they're priced at 35 cents per kilowatt per hour versus the cloud, which is a lot more. And this has to do with, there's no spine in the edge. There is no physical ability to do a spine. There's also no monopoly. And in addition, that's why the pricing is very different. Also, as far as access, the pricing of breakouts, whenever they're available in the middle of the city, are priced per UE and not per gigabyte like the carrier. So within the city and busy areas and busy uploads, we would use them a lot, and when we go on the interstate, we will use the carrier. One more thing, as far as green, is edge locations are starting to get powered and cooled by hydrogen, and that's a lot cheaper than connecting to the grid. Okay, next. So if we look at the generalization of this approach, if we tie the fog fragmentation with Lisp, we have significant savings compared to one spectrum from carrier, one consistent spectrum, which is very expensive. CBRS is free. And compared to compute on the cloud, the difference is the difference between economically viable and not economically viable for all kinds of Reality Plus applications like Nexagon. Next. Oh, this is a quick example. If I compare the upload of $4 per gigabyte using continuous spectrums for 1,000 frames per second, a frame is about 100 kilobytes, a detection frame. That's 260 terabytes per month. If I do it using one spectrum, it will cost me $1 million a month. If I do it using fragmented hotspots, it will cost me $72,000 a month. That's a big difference. And as far as compute, the most optimal numbers, when all the ducks are in a row, will cost you $100 for 1 million frames in the cloud. That's $260,000 per month. But at 35 cents per kilowatt hour plus depreciation, it will only cost me $10,000 per month in the edge. The only downside, I have to manage my own elasticity, my own roaming, and I do that with Lisp, and I can get to these numbers. That's it.
Any question? Seems not. So thank you, Sharon. We go to Dino next. So geocoordinates. The geocoordinates.
Yeah, thank you.
Here you go.
Okay, thank you. Okay, I'm going to present the Lisp geo prefixes. Next slide. So this presentation, this is an exact repeat of the presentation given November 2016. And it basically says there were no changes to the documents from 02 to 014. So all those revisions were just references and resetting the timer. So nothing has really changed in the document. Go ahead, next. Okay, so the changes from the initial document to 02 is basically, let's see, changes to reflect the new encoding that was going to match ISTIS, OSPF, and BGP encodings of geocoordinates. Okay. Basically, what's on the left is what the 00 draft produced, and then we moved it to what's on the right, and that's exactly what the all 4 protocols do now. We made altitude larger, and we are allowing for centimeter granularity, and that's why the latitude is being measured in milliseconds. Latitude and longitude are being measured in milliseconds. Okay. And then there was a lot of commentary about geocoordinates and privacy, so we put in a big section there, and you could read that and comment if you'd like, basically referring to BCP 160. Okay, next. So my Lispers.net implementation implements it, and this is a use case that I was trying to use. And what's this showing is these are entries, mapping entries in the mapping system. This is, we're looking at a map server right here that is being configured in VPN or instance ID 1000. And what's being accepted there are distinguished names as the EID. So San Jose, New York, Paris, London, Tokyo, SJC, and CDG. So there's cities and airports that are there, okay? Those things are being registered. So if you go down and look at the bottom left-hand side, this is an example of Paris. This is the actual mapping. Now we call this mapping a geoprefix because it's actually defining a point in the center of a sphere. So building a geofence, 3-dimensional, so it's just not a circle on a 2D space, but 3-dimensional. I guess you can't go below Earth, but you can certainly go up in the sky. So you can decide. So a geoprefix is what I treat as just like a regular IP prefix. It has a point, as you look down at the bottom there, and a /100. The 100 defines the radius of the sphere in kilometers. Okay. And then on the right-hand side, you can actually register a geopoint, where CDG is the Paris airport, and its GPS coordinates are there on the bottom in the right there. Okay. Next. So what you might want to do, and my implementation has a geotest sort of thing, and you can ask the question like, is the geopoint CDG in the geoprefix Paris, right? So when that lookup is done, what happens is the lookup is done on both of those EIDs. Those are distinguished named EIDs. And if you look at the bottom, that's the result. The result says the geopoint 49, blah, 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 34 is CDG. And these points are the decimal points of the GPS coordinates. And then if you look up the EID prefix Paris, you get the prefix. And then you can just do a GPS measurement and note, is that 49, 34, whatever, within that /100? And the answer is it is inside of it, and it's actually 23 kilometers away from the center of the sphere. So that's a use case. So, you know, what's a practical use case for this is, well, maybe you have a geofence around San Francisco, and you know there's an epicenter for an earthquake. You may want to send packets to all the EIDs that are within 10 kilometers of that epicenter. And so that's something you can do. You could retrieve all the IP address EIDs so you can send ping messages or TCP connections or whatever. Next. That's it. And we made a request for working group about a week ago, I guess, or last week.
Yes,
Yeah.
this is running a call for adoption. So if you support this document, please go to the mailing list and say so. Other than that, if there are any questions.
Hi, Alvaro Rotano, Routing AD. Just a couple comments. It's good that you made the formats the same as OSPF, ISS, and BGP. If you notice, those drafts didn't go anywhere in those working groups, mostly because, if I remember, people were concerned about publishing location, right?
Of what?
A publishing location,
Oh, yeah, right.
and you're letting other people know, say in the case of BGP, that my competitor knows where my router is, right?
Right, right.
And that may create many things. So having said that, if the working group wants to work on this, I can't stop you, of course. Just be conscious of that there's going to be a lot of questions around privacy, which is my second point. You said BCP 160. There's another RFC you want to look at. I think it's 6973 if I'm looking at my thing from here.
Okay.
But I'll put it on the chat.
Great.
That is called privacy considerations for internet protocols. And what we probably want to do is, besides, or maybe instead, I don't know, of what the security section says, actually have a privacy considerations, so that when people look at this and see geo whatever, they're going to immediately jump there, right? And then everything is going to be explained there, and how it's not going to escape, and how.
So distinguish it from the security consideration section.
Yes,
Oh, okay.
exactly.
Okay.
I've seen some people make it a subsection or a completely different section or whatever, just to attract the attention of people that want to look at this.
So can I comment on your first point?
Yes.
I assume, are you done? Or you have?
Yeah.
Okay. So what you register the mapping system about location can be static things like the example I used, right? Everybody knows where Charles de Gaulle Airport is and where Paris is. Should you assign geo coordinates to routers and hosts and things, that's a completely different matter. If somebody decides to do that, well, it's just like, should you sell a gun to somebody and it's their finger who pulls the trigger, but if the gun wasn't there, that's your point, right? Yeah.
Right. Yeah. Exactly. That's the point. That yes, there are many use cases that are probably fine.
Mm-hmm.
There are probably use cases that are not.
Yeah.
And or that it depends on who uses them and who sees the location and what they could do with it, and all this stuff. Right. So just make sure that
now the mapping system can restrict map requests. So you could be using the ECDCA draft, you can sign map requests, and then you know exactly who is requesting it, and they can be authorized.
Right. So all those things you want to put in
the
consideration, right? So that that way you limit who can see this.
Yeah, agree.
And etc. Just general comment.
Right.
Okay, thanks.
Hey, one thing I wanted to say is that specifically, if we're talking about different kind of families of what can be, like, for example, Charles de Gaulle, there's no privacy on it. It's a building that could be a hospital, can be, very specific public places. So we were having a discussion before about possibly we could actually group those in very specific instances or very specific ways of identifying them. And I think then you could actually have your geo-privacy kind of solved by saying these are the kinds of objects that are already known, so there's no privacy.
Public and private.
Yeah.
And we can use maybe instance IDs and say all the public ones. If you want to publish yourself to the mapping system and you want to be public and you don't care where your location is, then you register it to instance ID 1000, where if you want privacy, you do it to instance ID 1001, and then that's severely restricted on who can access 1001.
Yeah, I was thinking about, special emergency response. Those can be really good use cases where you actually want to see them, you want to know, and it might be that only certain people can actually look them up and have some restriction there.
Yeah, and if you want, you can obfuscate it or aggregate it where you don't have to give the geo point of where you are. You can give a geo fence that's 20 kilometers and you're somewhere in there, but they don't know exactly. Of course, a bomb could take out the 20 kilometers, but knowing exactly where somebody is, which room and on which street, that could be obfuscated a little bit.
Yeah.
There is a question from Sharon.
Yeah, I'm wondering, if we can combine GeoEIDs with ephemeral and sort of handle the privacy, meaning keep changing. They can coordinate with the person, just an address, which is right for a while.
I didn't catch all the words.
Me neither.
You broke up a little bit. Can you repeat?
Can you
again?
repeat, Sharon, please?
Yes, I was wondering if it's possible to combine geo EIDs with ephemeral EIDs so that they are good for a while.
Oh, you mean they're ephemeral in terms of how long they exist in the mapping system?
Yeah, and if you want to keep being known to be in a location, you have to keep generating new ones.
Absolutely. You could send a map register once with a short timeout, and when it times out, the map server will just remove them. So that will solve. We can solve that pretty easily with existing machinery.
Okay.
Absolutely. And if you want short timeouts, but you want them to time out quickly, then you just send refreshes just like any other map register. So, or you can send deregisters as well from the point who registers. So, yeah, we could certainly support that.
Okay, let's
Okay.
move on to the
Okay, satellite. Next. Okay, so I'm just going to go over some high-level goals. This is a little bit repeat from the last IETF, but a LISP overlay is something that can run over an IP delivery network, which is we call the underlay. And today, when you run this overlay over the capital I internet, we just use the capital I internet, however it looks, with independent of its interfaces and types of routers and everything that's underneath. We just use it, and we know it'll deliver packets to our locs. Okay. If a satellite network can deliver IP packets, it's just another example of an underlay. And so a LISP overlay can run over that. If you wanted to exclusively run it over a constellation, it will do just fine. And also, if the satellite network is part of the capital I internet, then it should work just fine as well. Point being here is that there's really nothing that has to change in the satellite network to make LISP run over it. So very much like LISP runs over the 3GPP network by running it at the very edges, or actually in the nodes in the 3GPP network, or the nodes that are in the ICAO network, the airline network. It just works because it's just different types of components that deliver IP packets. Next, please. Okay, so how does it work? It's pretty straightforward. There's no EID state in the satellite underlay, right? It only routes to RLOC. So encapsulated packets by LISP get delivered from RLOC to RLOC. As long as the satellite network can deliver IP packets, then there should be no problem with this encapsulation. Note that the satellite network is unaware of all the ID state as well as any overlay that's running over it. So it knows no difference if a TCP connection is going over it or LISP encapsulated packets. And of course, the underlay network can transport IPv4 or IPv6 packets and can be dual stack, just like the capital I internet is too. So we can use, you can use either address type to make it work, and a combination of both as well. When path optimization in the underlay is available, the RLOC record could help the satellite network route packets through it. So if you're using a satellite network with lots of ISLs, inter-satellite links, and you want to select the path, if you seem to have more knowledge than the satellite network, you can make suggestions. We've also talked about maybe satellite networks will be using GPS coordinates to find the downlink, which satellite is the downlink to where you have to go. So maybe if those GPS coordinates are in the mapping system that's associated with the RLOC of an XTR, then that pair can be used together. That's something we could add as a use case in a paragraph in the satellite spec. Next. So this is what it would look like. The top square is basically space, and you see the satellite networks that are up there. And there's lasers that connect them together in a vacuum, the ISLs are the inter-satellite links. And then we have up and down links that are usually run with RF type technology. And all we're doing is we're defining a new type of XTR called a GS, a ground station XTR. It's just a regular box that sits down there. That's a LISP XTR, and it just has an interface up to the satellite. And of course, what you do is EIDs are attached to the GSXTR. They come and go, and those are the ones that get registered with the RLOC that's associated with this interface right here. So LISP runs in those boxes, and the mapping system is on the ground. Next. So what are the sort of features you get? Well, EIDs can roam from GSXTRs to another and keep their connections up. So just like an EID can roam from like a VM can roam from one server to another, the EIDs are assigned to the VMs. It's just like a mobile device or anything else. And that's uses all the machinery that's in the EID mobility draft, right? And if you want the zero packet loss things, you can kind of assume where the EID is going to move. If it's moving, across GSXTRs and you know the direction, you can use predictive RLOGs, and packets could be going to the places you're about to arrive at. And so you can get zero packet loss that way, just like we did for the other use cases. GSXTRs can load split traffic across different RLOGs. They could be RLOGs of the satellite link or other links that the GSXTR has. So you can actually load split between space and ground if you need to, or use it as backup. And all packets that are encapsulated can use Lisp crypto, and therefore, if you want everything in space to be encrypted from XTR to XTR, that certainly is available. Okay. Now, GSXTRs can use an alternate path and use most of the traffic engineering stuff that we have in the traffic engineering spec. So for example, that first bullet there that says an XTR may send a packet up to the satellite that's in its aperture range. And that satellite then typically will send it over a laser to another satellite. Maybe you want to reach something half the circumference of the Earth. And so we would go up, over, and then down. That would be the typical case when it's not doing the even simpler case where it just goes to one sat and then comes down, okay? But for policy reasons, you might want to have the satellite go up and come down to an RTR. And I'll show you examples of the testing I've been doing, why that's necessary. So you may go up to a satellite, back down to the ground, back up to satellite, and then back down. So that would be something that would be needed. And as we realize, that's something that might be needed because maybe the connectivity is, maybe there's congestion in the particular orbit that this satellite is in, and it doesn't want to switch orbits for whatever reason, or there's congestion, or there's lack of connectivity. Because what we have now is we have a bunch of systems on the ground that are either static or moving around using a network that's totally mobile all the time, right? The satellites are moving 2.7 meters per second, or like 17,000 miles an hour. So these things are not standing still, and they're moving very fast. So if you try to do anything clever like synchronization, by the time you synchronize things, when you're ready to use it, they're going to already be out of date. Okay, so what we can do is we can use the Lisp underlay telemetry by using RLOG probing to actually measure the performance between XTRs on the ground, and we could actually find out how much variability we have in the satellite network as well. Okay, and then the second to last bullet, XTRs can offer EID multicast services by doing head-end replication. Again, head-end replication is there to offer a multicast service model to EIDs, even though that the underlay doesn't support native multicast. So it just does head-end replication to unicast RLOGs, where there's no reason why it can't do this over the satellite network if that's its only path. And also note that EIDs can talk to non-EIDs, and the path may be either the encapsulated path may be over the satellite network, and then it comes down and then it gets decapsulated and sent to a non-EID, or it can go even farther. So all the inner working stuff just works as well, because there's no special properties that make things difficult for an overlay to run on, other than the satellite network just has to provide IP address routing. Next. Okay, so the changes from, we wrote the 0.0 draft early this year and presented it in Philadelphia in June or July. And there were some comments about should the mapping system be put in space? Will it be needed there because of better latency if for some reason Lisp has to be put in the constellation? Well, at this moment in time, we see no reason that Lisp has to be put in the constellation. But there was another comment saying is, what if a GSXTR only has a satellite link and has no terrestrial links? Okay, will it be able to resolve things using the mapping system? And the answer is yes, because the mapping system is accessed via RLOGs, or routable IP addresses. And if the satellite network can reach that part of the network, and the services that are offered with most of the satellite networks today is that you can reach the entire internet by just sending something up. We said that that the GSXTR should have no problem, and the mapping system on the ground should be able to serve all these different combinations. Okay, and then what we also added to the 01 spec was a bunch of test scenarios that I'm about to present to you now. So I went out and I bought a Starlink dish. I mounted it at the top of the roof of my house, and I started doing some LISP tests on it. And when you look at this top diagram, there's satellites, there's Starlink satellites. There's about 3,500 of them now roaming in different orbits in LEO. And when you buy a Starlink kit, you get a dish that's about the size of a pizza box that's labeled dish there, and you get a Wi-Fi router, okay? So what I did is my personal laptop is basically acting as the GSXTR running LISP, okay? So I was able to do experiments. I connect my Wi-Fi to the Starlink Wi-Fi router, and I'm off and running. So these are all the test cases that I have tested. The top diagram is the case where its GSXTRs are directly connected to the satellite network using non-NAT. This is really important, okay? This has not been tested because Starlink router is a NAT device. The Wi-Fi router is a NAT device, okay? So it's hard to reach each other without doing the NAT traversal logic in LISP, okay? If you look at the bottom half, this is how it works with NAT. So if you say my laptop is there on the left-hand side, the only way I'm able to reach anybody else is to encapsulate my packets to the RTR. So actually, when the packets are encapsulated to the RTR, they go to the RTR's RLO. So the satellite network is delivering it to a colo down where the LISP RTR is located. It turns out the LISP RTR is running in an Amazon AWS VM. So it actually, wherever Starlink decides to downlink to, whatever colo, I think it uses a lot of Google infrastructure, that the packet then is routed from Google to Amazon to get to the LISP RTR. And then the LISP RTR then can encapsulate to the GSXTR on the other side, which is also doing NAT traversal. So that has been tested. Next slide.
You know, we should speed up a little.
Wrap up. Okay. So this just shows a case where the laptop on the left-hand side is talking to a LISP XTR that's in a VM, just doing encapsulation. So this is the case where the XTR is not directly connected to the satellite. We tested that. And then the top one was inner working. So can an EID, the laptop on the left-hand side, talk to a non-LISP host? And that's usually done through a LISP RTR, where we're using LISP NAT, where the EID is being translated to an RLO, so packets coming back can follow that path as well. And so that's been tested, and the bottom has been tested as well. Next. This is the case that hasn't been tested. This is where we'll have just the phone that's roaming, that's not running LISP, that will roam back and forth from a Wi-Fi or GSXTR AP. And I can do that on my laptop as well. So we can have EID1 move, or in this case it's showing EID2 is moving from one GSXTR to another one, and all the packets are being delivered by the satellite constellation, and the TCP connections are staying up because the EID address doesn't change, but just the RLOCs do. So this is more testing of that's going to happen. So this is just a call for if anybody wants to do testing. I need somebody far away from the Bay Area in California so I can do some testing. And when the satellite offerings do ISL, it would be nice to do an ISL testing if I can make that happen or judge that it's happening. So if there's any volunteers that want to join testing, that's fine. I'm even willing to offer to pay for your kit as long as you pay for the monthly cost for the service. So. Unless you can convince Elon to sell you free stuff. Maybe if any of you live in Ukraine, maybe we could do some testing. Huh? Right. So here's, and we're at, so the question here is this interesting work to make it a working group document?
First of all, there are any questions? Li Han is in the queue. Lin Han.
Go ahead, Lynn. Is he muted?
I don't know. So I have a question in the meantime, maybe. I didn't read the document in details, but my question is, does this document modify or extend the LISP specification in any way? Because it looked like just informational deployment document. if you wish.
It's documenting the fact that LISP can run over a satellite network and it requires no changes to the architecture or protocols. That's what it's documenting.
Okay. Has been this discussed extensively on the mailing list?
I don't think it has.
That would be good if we discuss a little bit more about this document before going to the working group
Yeah.
document.
So you want me to initiate a discussion of some sort?
That would be
Okay.
great, for example, I
Okay.
think. That would
Now-
be-
Can you hear me?
Yes, we hear you now.
Okay, so my question is, I saw that XTR and the EID bounding doesn't change, right?
You want to go back to the,
Yeah.
on this slide? Yeah.
So when the satellite link with dish is changing, do you trigger any updates?
Absolutely not.
Okay. Okay. Good. Thank you.
Basically, what happens in this diagram is EID2 is registered with the RLOC of the GSXTR on it's the IP address of the wireless interface to the Wi-Fi router. When the IED2 moves, it's now registered with the IP address of the right-hand GSXTR's Wi-Fi interface. And that's
Got it. Got it. So actually, you actually push all work to IP layer to advertise all connection between GSXTR to satellite.
No, it's in the mapping system. The EID to RLOC mappings are in the mapping system, and the mapping system doesn't know how, the IP address RLOCs. It doesn't know if it's attached on an Ethernet, a Wi-Fi interface, or anything.
Yeah. That's what I mean. Means that because the satellite network is not aware what is
Exactly.
behind. Yeah. Okay.
Exactly. That's right. Just like my EID is attached to my Wi-Fi router that has Comcast service, and if I talk to Padma and she has Comcast, you just change the satellite network there to a terrestrial, cable network, and it works the same way. Because
Yes.
all LISP cares about are EIDs and where they're located on the network, not what's underneath the network and
Yeah.
how the packets are being delivered.
Yeah. Got it. Thank you.
Okay, thank you. Let's move forward. We are running late. So now it's time for Prakash. I'm going to share the slides. Here we go.
Hello, everyone. This is Prakash Jain from Cisco Systems. I'll be presenting on the LISP site external connectivity draft. It's been there for a while, published for a while. Co-authors are Victor Moreno from Google and Sanjay Huda from Cisco. Next slide, please. At high level, the draft addresses the dynamic external connectivity for a LISP site. And especially it is for the EIDs or the endpoint which are unknown or which are not which are known but not registered to the mapping system. Means they can be external to the mapping system or external to the site, or they might be in the site but not registered yet. So draft essentially suggests the mechanism how to register the proxy ETR for those endpoints, and how to update those proxy ETR dynamically at the ITR or ETR wherever it is needed, and also how to request the PTR, and also how to specify the PTR in the map replies. Next slide, please. Now, one thing to note is that as part of this draft, we're not changing any of the procedures or any of the record formats which LISP standard specified. We are using them as it is. Only the contents, how the content should be to address this dynamic external connectivity, or have the external connectivity dynamically changing. Now, what the draft suggesting is that EID prefix is the distinguished name, either configured or it can be agreed upon distinguished name as per the Lisp name encoding draft. Now, the PXTR or PTR should be specified as part of the RLOC set, and those each locator in the RLOC set can be or may be encoded as per the Lisp VPN draft to cater the VPN environments. Means your PXTR could be in a different VRF or different VN. Additional information may be encoded as a vendor-specific LCAF type regarding the registering ETR or the PTR itself. Anything if needed. That's a specific. It's very specific to the implementation. Next. Similarly, the notification, there's no change as in the procedures of the record format. The EID prefix can be will be a distinguished name, and as per the Lisp name encoding draft, PTR will be encoded will be as part of the RLOC set. Now, the only difference here in the additional information is that now this information will be what map server or whoever is notifying wants to communicate to the ITR or ETR as part of the notification. Yeah, means we are not really changing anything in the message type. So whether the message being used for if the pub sub is used or whether the request reply will be used, it's a.
Can I ask a question or should I wait?
Go ahead.
Okay. So I understand that the message format's the same, but what's the reason you want to send a map notify?
Okay, so because it's a dynamic in the, what we want to have is a dynamic adjustment of the PTR. If there's something changes in the ETR, it has to be updated at the ITR. That's the main
You mean
reason.
if there's an RLOC set change or the metrics are changing?
Anything changes at the ETR.
Okay, so
even the routes.
So
route
that
has been lost.
functionality is documented in PubSub. So it means when you register the distinguished name, you want to be able to set the end bit. So it's a subscribe request. Okay, good.
Yeah.
I just want to make it clear you're using PubSub because you did say you have.
Means it's not limited to it, but it can be used. There's no notification can also be used, but the PubSub is also used.
Must it be used? The answer should be yes.
Okay.
Right? Because if you don't use it, then you don't know when the mappings are going to change. You got to wait for timeouts.
But maybe let's finish the slides and we can discuss this also on the
yeah, we can discuss that. Probably there's a little bit more we can talk about when talk about the use case. Okay. Next one, please. The map request, nothing is changing except that if it's needed, vendor-specific LCAF can be used to communicate the information regarding the ITR. Next one, please. The main change is in the resolution in the map reply. Today, when the EIDs are not known to the mapping system, or if they are not registered to the mapping system, negative map reply is sent. In the negative map reply, the RLOC count is 0. The draft is specifying that in that case, RLOC count must be non-zero. And it should include the PTR information as a part of the RLOC set, or the locator set. And with the RLOC encoding can be used either way, either as per the VPN draft or as a regular RLOC. EID prefix is same as the prefix in the negative map reply. Means it is a non-Lisp whole as per the procedures, as the standard procedure. Another thing is the TTL. TTL, the draft is suggesting that the shorter TTL should be used, because mapping can change. And that's the one of the, your question was that how it will be updated, because the TTL we are specifying is the smaller one. Now, it may not be immediate. You're right that PubSub will be more immediate, but it can be taken care by that. Additional information regarding the mapping itself can be communicated from the map server or whoever is sending the map reply to the ITR. Next, please. This is the example use case. It's not part of the draft, but it's here to show that this use case is using this draft to communicate the default PETR information to the ITR or within the LISP site. Now, this has been fully implemented and deployed in the field. Here, the EID prefix being used as a default ETR distinguished name, saying that, hey, this is the default path. And RLOCs, there can be multiple PETR in the RLOC as part of the locator set. And those multiple locators can be in the redundancy, or it can be in the load balancing mode based on the priority and weight as in the existing LISP standard. Now, the map request here is so there are two types of map requests here involved. One is that if somebody wants the default ETR information before the packet arrives, then map requests can be done using the default PTR distinguished name as an EID. And means with this, if there is additional information needs to be communicated, can be communicated using the vendor specific LCF type. Now, another map request is when really traffic arrives. At that time when the traffic arrives, the map request goes as a regular map request. Now the reply will be a negative map reply. In earlier case, the reply is the regular reply because this the EID as a distinguished name and the RLOC is the PTR. Now, when the actual traffic arrives, because the EID is the actual destination, the mapping system does not have that destination. So the reply is the negative, is kind of negative map reply, but with the modification of RLOC is non-zero RLOC. And the RLOC count is the non-zero RLOC count. Pardon?
It's a contradiction of terms if you say you received a negative map reply with a locator count of non-zero.
Yeah, I'm saying that it's similar to the EID, similar to the negative
What's
map
most
reply.
important is what's the action value in that negative map reply?
So
Maybe
we can call it like a regular map reply with the EID prefix similar to the EID prefix of the negative map reply, or either way. But to the point, this is not this is not communicating any action values. It is communicating the PETR information.
wait. You know, we should actually wrap up because we are in the last minute of the meeting. So, do you mind going to quickly?
I think this is probably the last slide I have, and next is just requesting for the working group adoption, and any comments and questions, so we can continue if we want.
To add something?
Hey, Praveen, I do have a few comments. So I went through your draft actually, and I came up with a case where I want to know exactly how you're doing this. Is that if you go in the case where you have a negative map reply, right, it's going to give you a range which is larger. If you look at 9301, it's going to give you a range which is larger. For example, if you're asking 4.1.1.1, it's going to motor respond to you for
that's
slash
exactly
8, right?
the point I was trying to make, that EID prefix, though we should not call it negative map reply. I agree with what Dino is saying. But the reason I'm saying it looks similar to the negative map reply because of that EID prefix, whole prefix calculation. It will be in that range, which is the larger range than the requesting prefix.
Yeah, exactly. So exactly this is where I think we need to be extremely careful, because at this point, before you may have the negative map reply, but you still don't have anybody attracting that traffic. Here, you're going to have the PETR attract the traffic of everybody else who are not yet up, because anything that's going to come up now are going to be actually attracted by that. Just like you were saying, is that you have a non-whole. What if somebody comes up with 4.2.1 point? There's no way that they're going to actually have a more, a shortest prefix is going to match it.
But that is not going to change any of the thing which we do with the negative apply today. So let's say today with the negative map apply, we said that action code is default forward. Right? There could be the action code map server can say. So here the purpose of this is that we want to default forward but encapsulated to the border. That is the purpose. So instead of taking the native routing path, we want to take the overlay path towards the border, and that's why it is functionality wise it's not going to change anything. But instead of taking the native path, it is taking the encapsulated path.
But it might be the ID that's not registered yet.
Yes.
She's saying you're wasting resources.
We might want to continue on the mailing
Yeah.
list. We are over time.
Yeah.
Okay, so one of the purpose for that is that why it is deliberately done, because we assume that when you are on the axis or the edge side, your box is smaller. So box may not have all the information, but when you are on the border, you have maybe PubSub already there, which already know about the.
Guys, yeah, the discussion is interesting. I'm sorry, but we are really over time. Thank you, Prakash. Continue the discussion on the mailing list, and we will reach that point about the working group adoption. It seems there are a few points to be clarified,
Sure.
and then we will progress as usual. Thank you very much.
Thanks.
Alberto, you have 30 seconds without slide if you want really to have a quick note on PubSub. 40 seconds.
Yeah.
You are asking too much. Go ahead.
Yeah, so first of all, thank you, Alvaro, for your review. Sorry it took us a while to get back to you. We have done that. And then I sent an email to the list about moving PubSub to proposed standard. So if you have any opinions on that, please go to the list, because this is something that has come over and over. And yeah, we want to see if we are going to move it to proposed standard. That's it.
So please go to the mailing list, express your opinion on this point. Thank you very much for participating. Sorry if we are 3 minutes over time. Enjoy the social event later on, okay? We have time. We don't have time about the chart. We will take it to the mailing list that try to make progress before 116. But now we are over time, so officially we go to the mailing list. Okay? We can. Duly noted.
Yeah. Thanks, everyone.
Thank you.